Throughout this assignment, we learned about the aspects of design and the calculations required to determine steel members within an industrial and domestic shed that are capable of carrying the anticipated loads. The assignment allowed us to gain a solid understanding on the forces that act upon primary and secondary members within a portal frame structure made up of the dead, live, and wind loads. This assignment tested our application of knowledge that we have learnt through our lecture and tutorial sessions, as well as the knowledge we had gained through our studies in Structures 1. Through this assignment, we were able to gain a solid understanding of industrial portal frame structures and their engineering requirements. Additionally, undertaking engineering calculations tested our knowledge of load combinations and previous understandings we had learnt throughout the course. It also reinforced previous knowledge we had learnt on load paths, as well as the use of roof and wall bracing to resist lateral loads. The assignment also tested our knowledge and allowed us to gain a solid understanding on the use of standards to determine wind speed, as well as the use of capacity tables to determine sufficient members. We started the assignment by researching into the members that are involved within the domestic shed. We were able to determine that portal frame structures are made up of rafters, purlins, columns, and girts, as well as horizontal and lateral bracing depending on the type of member connection seen throughout the frame. Pinned connections, such as the assumed connection undertaken in our design, require the use of vertical and horizontal bracing to assist in resisting the lateral load applied to the roof and wall frame from the wind. Through this research, we were also able to gain an understanding on the loads acting upon the steel members, as well as the load path and the supporting members within a steel frame. It also allowed us to understand the different members seen between a steel and timber frame structure, and how the members can differ depending on the type of cladding used. Next, we were able to take our designated parameters and determine the wind speed according to AS 4055. Determining the wind speed was critical to being able to determine the ultimate limit state and serviceability limit state pressure that would be acting upon certain members. Additionally, it allowed us to understand the wind load through pressure and suction that would also be acting upon certain members. During the first stage of the design process, we were asked to determine a suitable purlin capable of carrying the anticipated loads. Through this design, we learned about the potential dead and live loads acting upon a purlin. For example, the insulation, roof sheeting, purlin self-weight, and solar panels. The design again tested our application of knowledge learnt and allowed us to gain a solid understanding of the calculation requirements of a purlin. Additionally, we had to undertake a girt design. For the girt design, we had to make an assumption through our gained knowledge of the possible load path that no dead load would be acting upon the girt. This meant that only a live load in the form of the wind load would be relevant. We then had to determine the maximum pressure and suction that may be acting upon our girt, and determine a member capable of withstanding the anticipated load. The purlin and girt design allowed us to gain an understanding on the use of Z and C purlins, and how lapping Z purlins can have many benefits. Next, we were required to undertake a bracing design. The design of bracing tested our knowledge that we had learned in Structures 1, as we were required to undertake load path calculations and determine the moments acting around certain points. Additionally, we learnt and further extended our knowledge regarding tensile and compressive members, and how bracing is used to resist lateral loads within pin-connected structures. Undertaking the bracing design further reinforced our knowledge of load paths, and further developed our knowledge regarding bending moments. We were also required to develop a bracing layout that we believe would be seen on our design shed. Through this bracing design, we learned about the use of equal angles and square hollow sections, which depend on if the member is in compression or tension. After determining a suitable bracing layout and members, we undertook a rafter design. The rafter design tested our knowledge on compression again, and we were able to learn about the role fly bracing has in rafter design. We were able to understand that fly bracing assists the rafter in resisting lateral torsional buckling. Additionally, the rafter design allowed us to further our knowledge on bending moments and the deflection caused as a result of the loads applied to a rafter. Lastly, we were required to determine a suitable intermediate and end column for our domestic shed. These calculations taught us that pin connections did not take into consideration lateral loads, which further reinforced our knowledge on the use of bracing to resist lateral forces. The design taught us about the maximum dead load acting upon both the intermediate and end columns, and how the design requirements differentiate between the two. The assignment was very challenging and comprehensive, and we thoroughly enjoyed the knowledge that we were able to gain through undertaking the design of a domestic shed. The assignment allowed us to gain a solid understanding on loads applied to members, as well as the use of both standards and capacity tables to determine members. We believe the assignment was suitable in reinforcing prior knowledge learnt on bending moments, compression, tension, and buckling. Although we have found the assignment to be challenging at times, we believe the knowledge that we learnt to be extremely valuable. Being able to understand the engineering calculations undertaken within member design is critical knowledge when involved within construction, and this assignment, along with the exam and all other knowledge learnt throughout the semester, will go a long way to ensuring we have a sound understanding.